In this video, we're going to look at the exchange of energy between objects in the form of heat. And heat exchange is simply two objects that exchange thermal energy. So when we talk about temperature, that is the measure of thermal energy. So if something is hot to us, that is because it has more thermal energy than our skin, and our skin absorbs that energy and we don't like it, so we say that's hot or that's cold. Is our skin giving thermal energy to something that has less thermal energy? And heat flows from hot to cold, so if you leave hot coffee out, it's going to equilibrate with the surroundings, that is the rest of the universe, and cool down. So if something absorbs heat, temperature rises. If something loses heat, temperature goes down, and the increase is directly proportional to the amount of heat. And we need some kind of constant to tell us how much heat we gain or how much temperature we gain, and that is heat capacity, or C. And unit of C are joules per centigrade or joules per Kelvin. And heat is C times delta T. So the larger the heat capacity, the smaller the temperature rise. The harder it is to heat up if you have a large heat capacity. So heat capacity depends on the amount of stuff you have. So 200 grams of water takes twice as much heat to raise its temperature by 1 degree centigrade than 100 grams of sample. And it depends on the material. Asphalt has a much lower heat capacity than grass. It is much easier to heat up asphalt than it is to heat up grass. And if we look at specific heat capacity, we're just saying how much energy does it take to raise 1 gram of substance by 1 degree centigrade. And I have a table here. Now I have a star next to water because that's what we're going to use a lot. I don't need you to memorize the specific heat capacity of water, but just pointing it out here. You can see water has a higher specific heat capacity than every other substance on this table. And molar heat capacity is like specific heat capacity, except we're using moles instead of grams. And if we want to talk about heat and temperature, that's when we have to use our specific heat capacity, where heat is Q, and that's equals M, our mass, specific heat capacity, and temperature change. So this is an equation that we're going to be using here and in the next video as well. So let's see if we know how to use it. This is going to use the equation on the previous slide, but how many joules of energy must you put into 2 kilograms of water to raise its temperature by 2.3 degrees centigrade if the specific heat capacity of water is 4.184 joules per gram centigrade? Take a minute, see if you can figure this out. Alright, let's take a look. Remember the equation we're using, like I said, is from the previous page. Q equals mcs delta T. So Q equals 2,000 grams, not kilograms, we want grams. Specific heat capacity, change in temperature, and that's 1.9 times 10 to the 4 joules. And that's all there is to specific heat capacity. Not too bad. Alright, that's it for this video. See you in the next one.